Have you ever wondered what the future holds for our Milky Way? From merging with distant galaxies to evolving into something entirely unrecognizable, the possibilities are as vast as the universe itself. What will happen to the stars, planets, and even the supermassive black hole at its center? Join us as we unravel 7 fascinating theories about the Milky Way's future and discover the secrets hidden in the cosmos that could shape it for billions of years to come. Galactic Collision with Andromeda, written by Graham Wilson. The Milky Way and the Andromeda Galaxy are on an inevitable path toward each other, set to collide in about 4.5 billion years. This isn't a catastrophic crash as you might expect, but rather a slow-motion cosmic ballet that will reshape both galaxies over millions of years. Despite the immense scale of these galaxies, the vast distances between stars make actual stellar collisions highly unlikely. Instead, gravity will take center stage, pulling and warping these colossal structures in a dramatic merger. As the galaxies draw closer, they'll start to tug on each other with their immense gravitational forces. Stars from both galaxies will begin shifting into elongated streams, creating dazzling arcs of light across the cosmos. The Milky Way's familiar spiral structure will be stretched and distorted, and Andromeda's stars will swirl into an entirely new configuration. During this time, gas clouds from the two galaxies may collide, sparking bursts of star formation. These regions of new stars will shine brilliantly, lighting up the heavens in ways we can only dream of witnessing. At the heart of this collision lies a captivating event. Both the Milky Way and Andromeda harbor supermassive black holes at their centers, and as the galaxies merge, these black holes will spiral toward each other. When they finally combine, they'll form an even larger black hole, releasing immense energy in the form of gravitational waves. This event will forever alter the core of the new galaxy, likely creating a stunning luminous center surrounded by billions of stars. The result of this epic merger will be a new galaxy often referred to as Milkomeda. Its shape will be more elliptical than the spiral we know today, marking a profound transformation in the structure of our cosmic home. While this collision may sound alarming, it's a natural part of galactic evolution. It's a reminder of how dynamic and interconnected our universe truly is, with galaxies constantly evolving through interactions that shape their destinies. Dark energy and galactic expansion. The universe is expanding, and it's doing so faster than ever before, thanks to a mysterious force called dark energy. This elusive phenomenon makes up about 68% of the total energy in the universe, yet it's one of the least understood aspects of modern science. Discovered in the late 1990s, dark energy was revealed through observations of distant supernova that showed galaxies are not just moving away from each other, they're accelerating outward. This finding was groundbreaking and challenged everything we thought we knew about the cosmos. Dark energy acts like an invisible pressure, counteracting the pull of gravity on the largest scales. Instead of galaxies being drawn back together, dark energy pushes them apart, stretching the very fabric of spacetime. To grasp this, think about a balloon being inflated. Every point on its surface moves away from every other point as the balloon expands. In our universe, galaxies are those points, and space itself is the balloon. What's even more intriguing is that this expansion doesn't slow down. It speeds up over time, making the universe larger and emptier as billions of years pass. Theories about the nature of dark energy are still evolving. Some scientists suggest it could be linked to the energy of the vacuum in space, an idea tied to quantum mechanics. Others propose it might be an entirely new force of nature or even a misunderstanding of how gravity works on cosmic scales. What's certain is that dark energy holds the key to understanding the ultimate fate of the universe. Will the expansion continue indefinitely, leading to a cold, dark cosmos? Or could it slow down and reverse, collapsing everything into a big crunch? These are questions that physicists and astronomers are racing to answer. Dark energy doesn't just expand our universe, it expands our sense of wonder. It reminds us of how much we still have to learn about the cosmos and the forces that govern it. As telescopes like the James Webb Space Telescope and upcoming missions like the Nancy Grace Roman Space Telescope dive deeper into the mysteries of dark energy, we may uncover answers that completely reshape our understanding of the universe's past, present, and future. Stellar evolution and galactic recycling. Stars are more than just points of light in the night sky. They are the engines that power the universe and the source of nearly every element we know. Stellar evolution describes the life cycle of stars, from their fiery beginnings to their spectacular endings. When stars form, they are born from vast clouds of gas and dust called nebulae. Over millions of years, gravity pulls this material together, igniting nuclear fusion at their cores. This process is what makes stars shine and what drives the creation of new elements, transforming hydrogen and helium into the heavier elements essential for life. As stars age, their fate depends on their size. Smaller stars, like our Sun, expand into red giants before shedding their outer layers to form beautiful planetary nebulae, leaving behind dense white dwarfs. Massive stars, on the other hand, end their lives with a bang, literally. They explode in supernovae, scattering their elements across space. These dramatic events forge the heaviest elements like gold and uranium, which are then dispersed into the galaxy. Supernovae don't just create new elements, they also enrich the surrounding interstellar medium, seeding the galaxy with the raw materials needed for the next generation of stars. This process is what we call galactic recycling. The material from dying stars doesn't go to waste. It's recycled into new stars, planets, and even life. When these enriched clouds of gas and dust collapse to form new stars, the cycle begins anew. Over billions of years, this continuous process has transformed the universe, shaping galaxies and providing the building blocks for everything we see today. It's incredible to think that the carbon in your body or the iron in your blood was forged in the heart of a star billions of years ago. Stellar evolution and galactic recycling are a testament to the interconnected nature of the cosmos. They show us that nothing in the universe truly ends, it simply changes form, contributing to something greater. As we study the life and death of stars, we not only learn about the mechanics of the universe but also gain a deeper appreciation for our place within it. Each star's life is part of an ongoing story, a story that connects us all to the very fabric of the cosmos. Supermassive black hole activity. At the heart of the Milky Way lies Sagittarius A*, a supermassive black hole with a mass equivalent to about 4 million suns. Though currently in a relatively quiet state, black holes like this can undergo periods of intense activity, particularly when large amounts of gas, dust, or even stars are drawn into their gravitational pull. When this happens, the material forms an accretion disk around the black hole, heating up and emitting enormous amounts of energy. The future of our galaxy could see Sagittarius A* awakening, transforming the Milky Way center into an active galactic nucleus. This could create spectacular jets of energy and radiation, similar to what we observe in quasars in distant galaxies. Such activity wouldn't just light up the galactic core, it could also disrupt the surrounding region, triggering star formation in some areas while clearing out gas and dust in others. The black hole's behavior is influenced by the galaxy's evolution. As the Milky Way interacts with its neighbors, material from these interactions could fuel Sagittarius A*, igniting its activity. On the other hand, the depletion of available material over time could leave it dormant for billions of years. Either way, the black hole remains a central player in the galaxy's future. Studying Sagittarius A* helps us understand not just our galaxy, but the role supermassive black holes play in shaping galaxies throughout the universe. Whether it remains a quiet observer or becomes an active force, its presence ensures that the center of the Milky Way will continue to be a source of cosmic intrigue. The role of dark matter in galactic evolution. Dark matter is one of the most mysterious forces in the universe, and it plays a crucial role in the evolution of galaxies like the Milky Way. Although we can't see or directly detect dark matter, we know it's there because of its gravitational effects on stars, gas, and other visible matter. Dark matter acts as the glue that holds galaxies together, forming a vast halo around the Milky Way that influences its shape and behavior. Over time, the distribution of dark matter within the Milky Way will change, driven by gravitational interactions and the movement of matter within the galaxy. This could lead to shifts in the galaxy's structure, influencing the shape of its spiral arms and the density of its core. Dark matter may also play a role in the Milky Way's eventual collision with Andromeda, determining how the two galaxies merge and what the resulting structure will look like. Dark matter doesn't just affect the galaxy's structure, it also impacts its ability to form stars. By creating regions of higher gravitational pull, dark matter helps gather gas and dust into dense clouds where new stars are born. As the galaxy evolves and its gas reserves dwindle, the interplay between dark matter and visible matter will determine whether star formation can continue, or if the galaxy will enter a quieter phase. Understanding dark matter is one of the greatest challenges in modern astrophysics. As we study its role in the Milky Way, we're not only uncovering the secrets of our galaxy's future, but also piecing together the larger puzzle of the universe itself. Dark matter might be invisible, but its impact is written across the cosmos in every star, planet, and galaxy we see. The birth of new galactic structures. Galaxies are constantly evolving, and the Milky Way is no exception. Over time, gravitational interactions and the movement of stars reshape their structure, giving rise to new features like star clusters and spiral arm patterns. These changes are fueled by the interplay of visible matter like stars and gas, and the dark matter that forms the galaxy's unseen framework. This dynamic process ensures that our galaxy remains vibrant and active, not a static relic of the past. The spiral arms of the Milky Way are particularly fascinating. These regions are not fixed structures but rather areas of higher density where stars and gas pass through, triggering new waves of star formation. The result is a constantly changing cosmic tapestry that adds to the galaxy's beauty and complexity. These arms act as stellar nurseries, producing brilliant clusters of young stars that illuminate the galaxy's outer edges. At the galaxy's center, the bar-shaped structure plays a crucial role. It channels gas and stars toward the core, fueling the activity around the supermassive black hole, Sagittarius A*. This process can lead to bursts of star formation and even influence the galaxy's overall shape. As the bar evolves, it may drive changes that shift the Milky Way from its current spiral configuration to something entirely new, like a lenticular galaxy. The Milky Way's ability to create and adapt its structures reflects the ongoing processes that define galaxies. As it interacts with neighboring galaxies and absorbs new material, its appearance will continue to change. This constant evolution ensures that the story of the Milky Way is one of transformation, a reminder of the dynamic nature of the universe. Galactic interactions beyond Andromeda. The Milky Way is not an isolated entity, it's part of a larger family of galaxies known as the Local Group. While the collision with Andromeda often dominates discussions about the galaxy's future, interactions with smaller neighbors like the Magellanic Clouds also play a significant role. These dwarf galaxies are gradually merging with the Milky Way, contributing gas, stars, and dark matter to its structure. The large and small Magellanic Clouds in particular are creating dramatic effects. Streams of gas known as the Magellanic Stream connect these galaxies to the Milky Way, fueling star formation in our galaxy's outskirts. These interactions highlight how even small galaxies can leave lasting imprints on their larger counterparts. Beyond the Local Group, the Milky Way exists within the Virgo supercluster, a massive network of galaxies held together by gravity. Over billions of years, the Milky Way will interact with this larger cosmic structure, experiencing gravitational influences that could reshape its trajectory and structure. These distant interactions remind us that galaxies are not static islands but part of an interconnected cosmic web. The constant dance of galactic interactions ensures that the Milky Way's future will be shaped by both nearby and distant forces. From the pull of neighboring galaxies to the overarching influence of the cosmic web, these connections remind us of the dynamic and ever-changing nature of the universe. Each interaction is a chapter in the Milky Way's ongoing story of evolution and transformation. That concludes our journey through 7 captivating theories about the Milky Way's future. From cosmic collisions to the mysterious effects of dark energy, our galaxy's destiny is as fascinating as the stars within it. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.